Yes, class. Is it audible to you? Martin, Afnan, Nabiha, and Sarah. Right. So in the last class, we had started with speed and velocity. So we could only complete speed, average speed till average speed we did, and some questions of average speed was left. Okay, C class. Now see, the basic formula of speed is distance divided by time. That is rate of change of distance. Fine. Now see, speed and velocity. This is just a basic difference between the two quantities, that one is scalar and other one is vector. Now C class. Just remember, distance, when you involve distance, that quantity becomes speed. And when you involve displacement, that quantity becomes velocity. Fine. So I'll go one by one regarding speed and velocity. Now see, average speed, all of you will be able to manage because that just involves your basic division, right? But see, in case of instantaneous speed, we require calculus. So class, just one thing. Nabiha and Sarah, I think you weren't there from the first class. No, Martin and Afnan were there.
Yes, sir.
So those who have missed the classes of differentiation and integration, the calculus portion, because see class, that portion is very important. You will see by yourself that everywhere differentiation and integration is getting involved. So on Saturday morning, I'll take a class. All right. So I think Sarah, you should join. Nabiha, I think this you have also missed, no? Nabiha? Yes, Nabiha, you there in the class? Okay, Nabiha. Fine. So you also joined. Martin was already there, and Afnan, you were also there when we were discussing. So I'll tell you the timings. I think it's from 11:30 KSA timing. I'll just confirm you with the timing. Morning. Please join. We'll just do the basic calculus. No other physics part. Because today only you will see when we'll jump to instantaneous speed, no, continuously differentiation and integration gets involved. So this was the formula of speed which we had seen. So SI unit is meter per second and CGS unit is centimeter per second. Now, one very important conversion, you should remember that 1 kilometer per hour is equal to 5/18 meters per second. This conversion gets involved everywhere. Now, types of speed. You have two types of speed. One is uniform, other is non-uniform. Please have this in mind because velocity, the same thing will come. Acceleration, the same thing will get repeated. So regarding uniform speed is what? When speed is not changing with respect to time. Fine. 5 meter per second. So 5 meter per second at this point, 5 meter per second at this point, everywhere it is 5 meter per second. So when your velocity, when your speed's magnitude and direction isn't there in speed, when the magnitude isn't changing, speed is uniform. When will it be non-uniform? When any of the factors, like say at initial distance, it is 5 meter per second, then at the next distance, it is 6 meter per second, then again back to 5 meter per second. So in that case, it is non-uniform. Fine. And non-uniform is also of two types, average and instantaneous. Now see, average, when to use average, when to use instantaneous, that I'll tell you. But average part is very easy to solve. In average part, this was uniform and non-uniform, which we had seen. Basic formula of average speed is, we write now the formula for speed as distance by time. Average speed becomes total distance divided by total time. Find total distance by total time, that becomes average speed. All right. Now look, this was a basic question which we had seen. S1 is 10 meters given, S2 is 20 meters given, T1 is 10 seconds given, T2 is 5 seconds given, and we had calculated the average speed. Just for a quick review, let me just change the data. Fine, now at least you all should try and answer this. You all should also try by yourself, check what is your answer. All right, because I think in the last class only I had solved the questions, you people haven't. So S1 is 20 meters, S2 is 50. Fine. This is 5 seconds and this is 5 seconds. Find the average speed order. So this is the initial first distance. This is the next distance. This is the initial time. This is the next time. So what will be average speed? Quickly, everyone, quickly answer me in the chat column. Class, yes, class answers. This is a very easy question. How will you manage with other questions then? Only Martin has answered till now. Sarah, Nabiha, here nothing is involved. Just basics of your maths, addition, subtraction, that is involved. What will
Can you say the question again?
see, Sarah, the question is average speed. You have to find out average speed. And formula is total distance divided by total time. I think you were there, na, the last class, Sarah. So you must have written the formula somewhere. Total distance divided by total time. I think this is very obvious what to answer. Only Martin has answered till now. Afnan, Yasir, Siddika, I think you've just joined, no? See, Siddika, try to answer this. In the last class, I have made you write a question. This is initial distance given, this is final distance given. Otherwise, I'll call off your name and then you all have to answer one by one. So it's better answer whatever you're getting. Good, Nabiha, meter per second. Nabiha, meter. All right. So Nabiha and Martin, only 2 students. Yes, Afnan, what is the total distance? Just tell me one thing then. Okay, Sarah, you have calculated them separately. Okay. See. So at least 3 students have tried. And what about others then? Yes, Abdullah. Abdullah, see, a question is there. This is the question to you. This is the initial distance 20 meters, then 50 meters. Initial time 5 seconds, then 5 seconds. What is average speed? Average speed is total distance divided by total time. If you people will not be able to solve this question, you won't be able to solve the questions that we'll solve further. Right? At least 3 students have tried this. Good. See, Abdullah just came and he could answer. What about others? Okay, yes, I was asking you, Afnan. What is the total distance? Just tell me the total distance. Good, Yasir. Very good. Yes, Afnan. It is 70. Look, class, whenever we calculate the average speed, no, average speed is always total distance divided by total time. Fine. So very good, Afnan. Total distance is C. First distance is 20. Second distance is 50. That is the total distance. Now, Siddika, can you tell me what is the total time? Yes, Ruhina Siddika. What is the total time? Total distance Afnan has answered. 10 seconds. Very good. Because that will become 5 plus 5. Right? So this becomes 70 divided by 10, which is 7 meter per second. All right. Now see, in the next question, which we were doing in the last class, their velocities were given, but distance was not given. Right? Like in this question, we calculated the total distance by total time. Right? Total distance divided by total time. But in this question, velocity is mentioned and distance is not mentioned. But do we require this velocity? No, we require distance. because ultimately our formula is total distance by total time. So what did we do in the last class? What we were discussing was that this was 10 meter per second given, time is 3 seconds. So if speed is distance divided by time. Now I know speed, now I know time. My distance is unknown. How can I calculate? Can I calculate using this? Distance is equal to speed into time, right? Distance is equal to speed into time. Now look here. I got the individual distance now as, see, 3 into 10 becomes 30 and 2 into 20 becomes 40. So 30 meter, 40 meters. Total distance is 70. So now I have the total distance as 70 meters and total time as 5 seconds. So answer is 14 meter per second. First tell me, is this question clear to all of you? Then we'll be able to answer the third one, as well as I think third one came in your diagnostic test also. So I wanted to discuss that one. Okay, it's clear to Yasir and Abdullah. I hope it's clear to others also who are not answering. Please try to respond. Otherwise, it will become very difficult for me to also understand whether you are understanding, and your doubts won't also get clear. Fine. If it is still clear till here, no. Now the next question is a little one more step ahead of it. See, this question says that a body covers its total journey. Let's say this is the total journey. It covers its total journey. This is the total journey. Fine. Let's say this is one point, this is the another. In 3 equal parts, right? A body covers its total journey in 3 equal parts. See, what are those equal parts? Let's say this one, right? So from A to B, this is the first part, B to C, second part, C to D, third part, right? Entire journey into 3 parts with speed V1, V2, V3. Okay, class, one thing. If the body is covering its entire journey in 3 parts, I don't know what's the distance, right? And I want to find out the average speed. Question is saying no, a body covers its total journey in 3 equal parts with speed V1, V2, and V3. Calculate average speed for entire journey. Only speed is mentioned. Time is not given. Distance is not given. But our formula is same. Formula will remain the same. We will still use the formula total distance divided by total time. This will still remain same. But I don't have distance. I don't have time. Only speeds are mentioned, and that is not required in the calculation. One thing is it has mentioned, which you have to focus on, is 3 equal parts. It means, let me assume the total distance is 3x. Total distance is 3x. So can you tell me each part will be how much? Total distance is 3x. So each part, this is 3x is getting divided into 3 equal parts. So one part will receive how much portion of 3x?
X.
X. Very good, Sarah. It means this distance is x, this distance is x, and this distance is x. That's why no, the entire will become 3x. I have assumed that total distance is 3x. Right? Just a second. So entire distance is 3x. So now each part is receiving x, 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 right? This is the distance. Now at least I have the distance with me. Let us see whatever will be the final distance. All right. But currently I have this. Now regarding time, time is also not given. But we have the formula, one formula only that is required. I've told you, no, here only one formula. Just a second. Just See, so we have one formula, speed is equal to distance divided by time. So I have distance, though I have assumed it myself, that will get cancelled at the end, and speed is already there. So what will time be? Time will become distance divided by speed, right? So just talking about the segment A to B, just focus on this segment AB, only this part, right? So Nabiha, can you tell me, if V1 is the speed, X is the distance, what will be the time for this part become? I have written the formula for time here. Speed is given, distance is given. So time should be from this formula. Nabiha, Nabiha, you're present? V1 divided by X. Very good. Speed, see, thing is that, Nabiha, you have written speed initially and distance later on. Look here. We are writing time is equal to distance divided by speed. Now, in your case, what is happening? Speed is coming up and distance is coming down. So is it correct according to you? Distance divided by speed. Right. So you have to reciprocate it. It means this is X by V1. Distance by speed. So this is the time and this is the distance. One part is solved. Now I have the distance, I have the time. Second part, distance is there, X. But what about the speed? Abdullah, can you answer? The second part, what should be time, T2? X by V2. Very good. This has to be X by V2. Lastly, so now I have second time also, I have distance also. Now the last part, V3 is the speed, X is still the distance. This smaller segment is X, right? Yes, Yasir, Mohammad Yasir, can you tell me what should be the time for this part? Yes, Yasir. Speed is V3, distance is X, X divided by V3. Very good. So this is X divided by V3. Now see, all of you all only have collected all the time. You all only have collected all the distance. So we have distances, we have time. Now at least we can get average speed. Now putting into this formula, Martin, can you tell me what is the total distance? I have to put in this formula, no? I have individual. How much?
And S1 plus S2 plus S3.
Yes, that is, what is the answer? Very good. S1 plus S2 plus S3. So when you add all these, what are you getting?
3.
3x. X plus this one X and this X. That becomes 3x. Otherwise, also total distances, we have assumed it as 3x. So directly also you can write, or you can add it individually. So in average speed, total distance is 3x, right? Coming to total time. If I have first time as T1, second time as T2, third time as T3, time is not equal for every part, Abdullah. 3x you can write, but 3t you can't write, because nowhere in the question it has been mentioned that time is equal. It is saying that, yes, equal distances are there. Yeah. So you can take 3x the way I have also taken 3x, because distance is equal. But the problem in this question is this only, that time is not equal. That's why we have to perform all these calculations. All right. So individual time we have calculated T1, T2, T3. So what we can do, total time will be add all the time. It means x by V1 plus x by V2 plus x by V3. This was T1, remember? This was T2 and this was T3. All of you have answered this individually. So total time would be this, total distance is this. Now you just have to solve it. See, how can we solve this? Look here. Can I take x common from here? If I take x common in the denominator, I'll be left with 1 by V1 plus 1 by V2 plus 1 by V3. So this x gets cancelled. This was a quantity, no, that was assumed by us. We had taken 3x. X wasn't mentioned in the question. So in my final answer, x shouldn't be there because that is not mentioned in the question. That is something that I have assumed. So that's why 3 in our calculation, x is also successfully getting cancelled. And now see in your answer, 3, the number is left, and V1, V2, V3, all the 3 variables are given, which are already mentioned in the question. Now see, this is your answer. Or what you can do to further simplify it, or if you want to solve it further, you can take their LCM. LCM will become V1, V2, V3, right? And this will become V2 into V3 plus V1 into V3 plus V1 into V2. So this becomes 3V1, V2, V3 divided by V2, V3 plus V1, V3 plus V1, V2. This is the further simplification of it. 3 by V1, V2. Okay, right, Abdullah? Just I think you have missed this part, the LCM part. Good. All right. Note this down, all of you. Then we'll discuss when to use average and when to use instantaneous. Note this down. And any doubts in this while writing, let me know.
Okay, sir.
Just text me done once you have written. Then I'll start with the next topic. I think Abdullah has only written to me. See, class, now I wanted to discuss with you what is meant by instantaneous speed and what is meant by average speed. The solving part of average speed was where you had to use division, and in your instantaneous speed, you have to use calculus. Now, see, class, one thing. Here, no. In when you how to identify, if suppose a question is given to you, and in that question, you have some data. Now, how will you identify whether you have to find average speed or you have to find instantaneous speed, right? So in that case, if you are getting a time interval, let's say from 9:30 to 10:30, from 2 p.m. to 4 p.m., right? A certain duration is there from Monday to Friday. A duration is there where there is a beginning and there is an end, right? That time duration is there. In that cases, you will use average speed. Fine. In that cases, you will use average speed. But suppose if I ask you, tell me the speed exactly at 2 p.m. There's no duration. From 2 p.m. to which time, this is not mentioned. What is mentioned to you? This is directly mentioned to you that tell me the speed exactly at 3.005 seconds. In such cases, you are going to calculate the instantaneous. Fine. So the example also which I have written says this only. From T1 is equal to 2 p.m. T2 is equal to 6 p.m. Time interval is 4 hours. So we use average. Then instantaneous speed at a particular instant. Speed at a particular instant for x1 T1, for x2 T2. When you have a particular instant. So if you when to use the difference form, the way you have been using, when duration is given and time interval is mentioned, you calculate average. When exactly particular time is given to you, a very instant, a very short moment is given to you, you use instantaneous speed. Fine. This is what is meant by it. Now, this is the solving part. Those who have not done, it will be a little difficult for you. Do one thing. First, note down this part. Just make a note point and note down this. When to use average, when to use instantaneous. Now see class, the rest of the questions, no, which are how to solve instantaneous speed. So for instantaneous speed, these are just the questions are just based on direct differentiation. Fine. The questions are just on direct differentiation and integration. So that part, when I'll take the class on Saturday, because half of you will be able to understand, half of you will not be able to understand. So let us just have the class on Saturday. So on Tuesday, the rest of the questions we complete. All right, and others also will get the time to just have a look on differentiation basis. All right. Now, coming to the next topic, which is acceleration. So acceleration also involves your same thing. Instantaneous, the calculations are also there. Now, look, what is meant by acceleration? Acceleration is simply rate of change of velocity. The way rate of change of distance was. Yes, Sarah. I'll share my number. Let me share it. Okay, I'll type after this. So see, when you have rate of change of velocity, when distance was getting changed with respect to time, we called the term as speed, right? I'm not coming to, I haven't jumped to velocity because velocity is also, okay, let's do one thing. Let's just understand the basics of velocity also. These questions I'll do it later on. Once we just continue with the class, at least others also, because like Sarah has joined in the last class only, some students. So those questions practicing we'll do later on. Let's do the theory part first of this. See, when rate of change of distance was there, no, then we had obtained the term speed. And when rate of change of displacement is there, then we had obtained the term velocity. Right. So when it's just the placement of distance and displacement which changes your speed and velocity. Rest of the formula is also same. Speed was distance divided by time, and your velocity is displacement divided by time. Fine. So why is it different? Why is there a difference between speed and velocity? There's a difference because remember when we had solved the questions, those circular questions and the questions in a straight line, those types of questions, answers for each part, distance and displacement, were different. It means if your distance is different, your answer will be different. If your displacement is something else other than distance, it will be different. So that's why we say velocity and speed, they are two different terms. So rate of change of when displacement comes. Remember, displacement was the shortest path. You just join the initial and final position, your displacement will be obtained. And the longest path, not the longest, the entire path that is covered, when you consider that, that is distance. So in calculations of speed, even in average speed, we used to calculate the entire distance. If distance wasn't mentioned, we intentionally calculated it, right? In velocity, rate of change of displacement is mentioned. Means whatever is that, even if your displacement is 0, you will still consider that 0 only in your answer. You will not consider distance. Now again, now uniform and non-uniform is not difficult for you to understand. What is meant by uniform? What is meant by non-uniform? If the body is covering equal displacement in equal interval of time, you have uniform. And if it is not covering, then you have non-uniform. But just one more point gets added up in velocity, because velocity is a vector quantity. What are scalar and vector quantities? Can anyone tell me? Okay, I'm just giving the definition. At least tell me whether I'm giving the definition of scalar or vector. This quantity just has the magnitude. Which quantity is this? Scalar or vector? Just the magnitude, no direction.
Scalar.
Scalar. Very good, Abdullah. You have also answered well. Direction and magnitude. See, scalar quantities just have magnitude, and the vector quantities have magnitude as well as direction. So in speed, we only used to write till this part and our work was done. But see, now in case of velocity, the quantity has magnitude as well as direction is also there, right? So when magnitude and direction both are present, then in those cases we get uniform velocity. And when both of them do not both of them keep on changing, then this is non-uniform. So here you just do not focus on magnitude, focus on direction also. Fine. So this is what is meant by it. Now, non-uniform is also of two types. Survey speed was also of two types. Non-uniform speed, average and instantaneous was there. Here also you have average and instantaneous. Now, how did we calculate average speed? Total distance by total time. Now you will calculate an average velocity, total displacement by total time. In average speed, you used to calculate total distance by total time. In average velocity, you will have total displacement by total time. This is just the difference. And instantaneous calculation is exactly this. If you all want, I can start with instantaneous calculation also. If you want to do it after Saturday's class, then I can do that also. Let me know how do you all want to go about. All right. This question I'll do. Note down this first, velocity. And also in the chat column, let me know how you all want me to go about with instantaneous calculation. If you want, I can discuss the calculation part right now also. Or if you want to first attend all the classes of differentiation and want to do. Okay, afterwards, no? Fine. After Saturday's class, we'll then discuss. So we have the next class on Tuesday, no? Whatever questions are left, we'll do. Fine. So Saturday, 11 o'clock, I think you'll have your class. I hope you all are available 11 o'clock Saturday morning. We'll just do calculus. First chapter, you all will be able to manage by seeing the playlist. And do take the playlist. First chapter, you all will be able to do. It's a very easy lesson, just basic dimensions and the formula part is there, that you'll do. But calculus, it's difficult to see by just seeing the video lectures. So we'll have the proper class for it. And Saturday, I think all of you have your holiday only there. And others also, those who have attended first. And if they want to get a revision of it, want to attend it, those also can attend. It's not compulsory for just the new students to attend. Okay, one question for all of you regarding average speed. Sorry, average velocity, average speed we have done. It's an example only. A body starts its journey from A point, reaches a point D. This separation is 10 meters. The body covers this in 3 seconds. Fine. Then the body goes to C point. This distance is 5 meters. The time is 5 seconds. Fine. The body returns to this point. It was going, no. Now it is returning and till here only. Till 3 centimeters the body covers. Fine. In 2 seconds and stops. This is the final point. Let's say B point. What is the average velocity? You have to find average velocity. What is the formula? Total displacement by total time. And how do we calculate the displacement? Just take the initial point, find out the final point, and take the separation between them. Try this question, then we'll be able to solve the next question. At least try this one. So 10 meters in 3 seconds, then went ahead 5 meters. Now 5 seconds have been elapsed, then returns to 3 meters. What is the displacement? Total displacement by total time. All of you should at least try whatever answers you're getting, whether correct, incorrect. That's okay. I'll discuss it in any ways. That is not 50, that is 5 seconds. This is not 50, this is 5 seconds for this part, DC. I think just check your calculations once again, Sarah. Total displacement. Okay, Sarah, in the chat column only answer. Don't unmute yourself. Tell me, Sarah, what was your displacement that was coming? Close. Nabia, check your denominator. And Sarah, please tell me what was your total displacement that came. See, all of you, some of you are calculating average speed. So students who have at least tried, Martin, Sarah, Nabiha, these 3 students. What about you, Abdullah? Abdullah, Afnan, Yasir, Siddiqa, at least try. Only one student has got the correct answer. Abdullah. Good, Abdullah. Others, see, you people are also getting the correct answer. Like Nabiha, you are also getting, Martin is getting, Sarah is also getting. But you are calculating the average speed. Question is average velocity. See, how will I calculate average speed? Let us just go by speed first. Average speed, fine. Let's calculate average speed so that at least you can see the difference. This is speed. Average speed. Here we have average velocity. What is the total distance? What is the total distance that we have to take? First, the person went from A to D. So total distance, 1 is 10 plus. Next distance, the person went here, 5 meters. Then again, the person came back, 3 meters, right? Good, Yasir. Correct answer. Please add the units, meter per second. Very good. So this is 3 divided by what is the total time? Initially, at first it is 3 seconds, then 5 seconds, then 2 seconds. So this is 18. 18 divided by 10. This is what you all were getting. 1.8 meter per second. Yes, Sarah, but is it average velocity? No, this is average speed. What you are getting, no, that is mathematically correct. But this 1.8 meter per second is our average speed. Can anyone tell me what is the displacement apart from Abdullah and Yasir? Anyone else apart from these two? Martin, can you try? Displacement. Displacement. In just join the initial and final point. Okay, just tell me one thing. Entire distance is how much? This part from A to C. Look on the screen, class. A to C, what is the total distance? Yes, Sarah?
18.
18 from A to C. 18 was when he returned back from A to C.
15.
This part, 15, right? So C class, this entire distance is 15 meters. This entire distance, right? And just delete, we have, what is our initial point? Initial point is A point. Final point is B point. I want to find out this separation. This is the displacement. I just want to find out this separation between A to B. A to B, that is initial and final. Entire is 15. If I delete this from the entire, will I be left with this? Now can anyone tell me what is the displacement? Class, entire is 15. Here, this is what I'm looking for. What is the displacement? No, Sarah. See. Forget that extra 3 which you are getting. Just look in this manner. You have a straight line. Yes, Martin?
15 meters.
15. See, 15 is total from A to C. I am asking all of you A to B. A to C is 15. B to C is 3. What is A to B? It's like you have a line. See, this is 15 meters from A to C. This part is 3 meters from B to C. I am asking all of you, how much is this part from A to B? Because this is my initial point, this is my final point. So this is what is required by me. If it
12,
is 15,
12,
just this
12.
part is 12. 12. Yes, Martin. It is 12. Do you understand, class? See, the entire was 15. The person was going from here and came back to here. But when we were calculating the distance, we added all the distances that was covered, because definition of distance is total path covered. Even if the person is stepping back, which is 3 meters, we'll calculate, we'll add it. That is the total distance. That is the total distance. Now see, in the velocities calculation, we require displacement. Remember all the circular questions also we had seen. When it was distance, we used to calculate entire perimeter, entire curve of the circle. And when it is from displacement, we just directly used to join initial and final point, right? So in average velocity also, when you're calculating average velocity, you just join the initial and final points. So initial point is A, then the person went to C point and came back to B. So your final point is B, not C. And now you are not concerned how the person went, whether the person went from A to D, D to C, C to B. No, you just need to focus on started from A, landed to B. Your initial point, your final point, and the separation between them. That's it. So entire was 15. Came back to 3. Just delete 3 from 15. 15 minus 3. How much is left? 12 is left. Is this clear to all of you? Why is this 12 meters and not 18 meters?
Yes, ma'am.
Right? Entire is 15. Somewhere in the corner of your notebook, make it like this. Then only you will be able to remember. This entire was 15 meters. A to C. Person came back to 3 meters. This was what our question was. That is 12 meters. Then only 12 meters plus 3 meter will give you 15 meters back. Now see. To see the difference. What is the total displacement? Displacement is just 12 meters. In displacement, don't go by each and every point. That's why we discussed in displacement. So this is just 12. And time is a quantity that will never decrease. That will always increase whether you consider distance or displacement. So time will definitely be 3 plus 5 plus 2. This becomes 12 by 10, which is 1.2 meter per second. These are the differences between average speed and average velocity. Is it clear? Yes, no. Apart from Martin and Sarah, others, have you understood? Siddhika, clear? Nabiha, Afnan, sorry. Oh, note down this. Class, just note down this question. I won't discuss it right now. Just I want you all to write it down and at least try once in the next class, because not much time is also left. So in the next class, I'll discuss this. And apart from this question, just those differentiation and calculus questions are left from your velocity. So on Saturday, we'll have the class on differentiation. So at least you will be able to solve this. All right. This question I want you all to try. It's similar. Someone is going covering a certain distance, returning back, then covering again. All right. So just note it down and text me in the chat column. That done. Done means you have written the question. And at least try to have the final answer with you, because I'll discuss this in the next class. I'll begin the class with this question only. Okay. I think only Sarah, you need the number, no? Or anyone else also needs. Then I'll only share to Sarah. Okay, let me give the number. Okay, I have written my number. Those who require, put the code +91 for India and note it. And class Saturday's timing 11 a.m. KSA timing. All right. So if anyone is there here in India, for you it will be 1:30. All right, 1:30. All right. So if you have written this, Sarah, you're saying something?
What about UAE timing?
UAE, it's I think 1.5 hours gap. No, see, Indian IST timing it will be 1:30. How much difference is there?
Oh, I'll calculate.
1.5 hours. No, I think. Okay, 1 hour. Abdullah, it will be 12 p.m. over there. Okay, okay. So if it is 1:30 here, then 12 noon for you. Okay, okay. So 1.5 hour gap. Fine. So if it is 1:30 here, so Sarah, it would be 12 for you. Done, Siddhika. All right. So those who have completed, you can leave. You will not have your class assessment today.
Thank you, ma'am.
Okay, thank you so much.